So in this video, I'm going to show you the database we're going to use. First is NTP ICE. In here, I can just Google it, NTP ICE, and you can find all different data set here. So this is the page, and here, data tab. So if you click the data button, you can find all these data set. So you can take your time and read later. I'm gonna use this data, acute oral toxicity. So it has in vivo and slick data. And also they have a mixtures and active ingredients, which is a single molecule. So download it. And open it. So in the notes tab, you can find the name of column and the description. And this data tab is the data we're going to use. So there's chemical ID, like name, cast number, TTX ID, and details about the animal test data. So you have a LD50, and if you go down, there's another type of endpoint, but I'm not going to use it here. I'm focusing on LD50. So in total, I have here, we have 16,000 rows, but you see some of chemical has a duplicated data. I mean, they are the same, but their their animal testing results are different. So you see here, so these are the same compound, but different experimental values. So we need to handle this issue. If we think errors are too high, we may throw away this data set, or we can make our own standard to create data set. And if the distribution standard deviation of these numbers are too high, maybe based on the cutoff, we can remove the data set. But in fact, in this throughout this video, I'm going to use lowest value among them. The reason is toxicity issue should be handled from the conservative perspective. I mean, if the compounds have range of values, then it's much safer to take the lowest value, because lower LD50 means higher toxicity. So these range of values can be obtained because of the range of dose of these chemicals to the animal, and each different test can be maybe conducted with a different range of doses. So the estimated LD50 may be different, and if there's a different information, then maybe it's safer to it's helpful to find safer molecule if we develop the model based on the most based on these most toxic case, so that we may never lose any molecule that can be harmful, predicted as safe. So to make the robust prediction, I think it's better to take this value, which is the most toxic among these value, so that model also predicts based on the conservative attitude. So that's my idea. But there can be different opinion, so it's okay. Now you don't always need to stick to specific condition. Maybe if you think it's better to use mean value, maybe it's better to use mean value or median or something. But anyway, we need to handle this issue, and throughout this course, I'm gonna just use the lowest value. Okay, so this is the data set for model development. And another one is ECHA biocide. So ECHA uploaded the list of active substances. So we can check it here. I have read and accept the terms. There's a legal notice. And you can find the list of active substances, and you can download Excel files. So here you can find simply the list of biocide. So there is a notes, and below it data list of biocides are listed. Here it has a name, and we also have a case number, so you can use both to get the data. What I mean by that is if you use Pubchem, you can search it with the name. Let's say this. Oop. I'm trying to get some compound. It's not working. Okay, I'll take compound from here. So it has a chemical name. Let's say I want to find oxamide. I can search it here, and I can find the structure. This one's mouse code. Before pubchempy API was available, the most tedious job before model development was collecting all the data set. In that case, I search the compounds and find the structure. In the worst situation, I need to draw all the structure. But luckily, we have pubchem this one. So if we have a name, then we can automate the downloading process. So please go installation and install this library, and then we are going to use it to download all the structures, because we don't have we don't have Smiles code here, so we need to bring Smiles code to this file and also to this file. We only have name, so we really need to download all the structure, and pubchem will help us